Let's start with the first one. Um, yes. Describe the association between the year and the distance jumped from the years 1960 to 1988. 1988 is around here, and 1960 is obviously around here. So what is the relationship there? What is the association? It's a positive association in about what? Yeah. So not necessarily the larger the year, but the as the years went by, the the people were able to jump longer distances. By the way, this is like whenever you're jumping and then you land on the sand, that's what it is. So you can tell what it is and you can actually draw a line through it. You should be able to. So you can see that there is a positive association for that one. You can say positive association. Associative. But I also want you to tell me what is the association. So I usually write it when I'm looking at this kind of information in research documents. I make notes on the side. I don't write the whole thing. I'll just put the higher the years, the higher the distance. And you don't have to write it this way, but that is just a very quick abbreviation of what it is. Yes, as the year increases, so does the distance. Good. Uh, the next one. Describe the association between the year and the distance jumps for the years after 1988. What happened there? Yeah, so after 1988, basically it began to it began to decrease, right? So as the years decreased, wait, that's not there. When the years decreased, so did the distance in the jump. What do you think happened there? These are competitors. So why do you think that happened? What do you think after a particular year, it just went down? Hmm. If you were, I guess if you were talking about one person, that would make perfect sense. Let's say you reach a point that's your max, and then from there you go down. But this is the winning distance about all men who compete. So if you're competing every year, do what? Yeah, it could have happened if it was just one person. Yeah, like why do you think that happened, Candy? The what? Like the five. This is just a jump though. This is not a running. You're just jumping. So I'm guessing what you're trying to say the equipment was different. Okay, that's valid. Yes. That's another one. Yeah. What I mean, if it's just one long shot, maybe there aren't as many competitors, and the ones that happen to reach the highest are not probably the best ones in the world. That's another one. So those are very valid reasons. Uh, from a competitive perspective, I would say maybe, just maybe, the setup is a lot more difficult. So it's harder to hit those marks if you have more obstacles, or it's just the setup of the competition is a lot more strict. Just like when we have people who ice skate back in the day, years ago, you could just do a couple of things and it was like a perfect score. Now you have to do all kinds of flips in the air and you still don't get a perfect score. So it just gets, the judging becomes a little more strict. So that might have been one of the reasons why it went down that way. Other than that, I don't see why. And what do you think happened over here with this guy? Yeah, maybe just this one guy that happened to be extremely good that year, and then maybe he got injured after that, or maybe he died, and he didn't come back for the next year, so he only won one time. This is all the champions, basically, all the winners. So that guy only won one time, and that was it. Never came back. All right, number 7. You can ask Aaron about that dot. Yeah, it never went away this morning. Yes. Exactly. It is not linear because the line is not consistent. It breaks, right? It's non-linear because the trend breaks. It changes direction. So yeah, that'll be it. And for number 7, identify the outlier. We just identified it and we talked about it. Compare the scatter plot that shows no association to one that shows a negative association. What do you think? What are the differences? Number 9? I did. Number 8 is basically, we already talked about it, the outlier. Yes. So, yes. Okay, like that. So that's good. Basically, no association. You can't draw. There's no direction for the dots. They're everywhere. Whereas negative association means that they're going down. Meaning the higher one gets, the lower the other one gets. They're going opposites. Please do not confuse the two. Negative association and no association are two completely different things. No association is like that one. Can you make sense of that? No, they're just everywhere. You can't predict anything. Other you can say, well, yes. And for the negative, you can predict. If I don't have anything at the bottom, you can say, well, it's going to keep going down, right? If it's going up, it's the same way. But with that no association right here, you can't tell anything. They're just everywhere. And you might have an extra point. It'll be randomly everywhere, too. All right. Number 10. Can somebody give me an example how you could use that graph? What kind of situation would be used? Well, it is a negative association, but an example, yes. So something is, what is the year though? What is the X? So, for example, what you're saying is that, well, that would be different. It would be hard to do that. Okay, is that the only one? That wouldn't quite work because you're saying that as the years get higher, lower, but the years don't decrease, they increase. So hang on, what? But it ought to increase. Yes. Which one is price and which one is customers? So, are you sure? Yeah, so the X is the price and the Y is the customers, right? So whenever you're selling it for $1, you have 10 people. Whenever you're selling it for $2, you have 8, and then it keeps decreasing as it goes. You could use use of what do we call it, regular machinery instead of technology, and use that. If you say as the years go by at the bottom, as the years increase, then the use of machinery will decrease. That it is non-technological. But they wanted you to use those numbers. So those numbers will be good when you're selling stuff. What about 11? What would it be? No association, but what would be a good example? Yes. The what? Yeah, the length of time that it took 10 people to grow 10 inches. Well, 2 inches. That could be one of them. It's kind of scattered. That makes sense. Because if it tells one person just, let's say, 1 month, depending on the age, and they grew 5 inches, that's kind of crazy, but it happens. You see people who are very, very tall here, like Ayana. And then, for example, Micah, let's say it took her 10 months just to grow 4 inches. That's perfect. All of you grow at different rates, and there is no association with it. However, if we took a lot of people, you will see an association overall that the older you get, the taller you get, or generally you do. All right. This one we're different. Describe what you might see in a table of bivariate data that will lead you to conclude that the scatter plot of the data will show a cluster. You have to go back to last semester with the bivariate data, which is basically this. For example, you're looking at stuff that you want to buy. You want to rent. 1 hour, 2 hour, 3 hour, 4 hours. For this one, it'll be $2 plus $2 of initial fee. This one is just $4. So you will think. So this one will be 4, and then 2 times 2 is 4 plus 2 is 6. 2 times 3 is 6 plus 2 is 8, and this will be 10. That'll be 4, 8, 12, 16. Do you see the difference? You can put that in the same graph, and you will see bivariate data means that you have two different graphs, lines on the same graph. So we should be able to see the difference between the two if there were scatter plots on a graph. Why? Let me give you a visual. What if it was this way, and then you had this kind of, and then you had this? Well, generally they're two different directions. You can still see it, right? You can still see it. It will work better if you had this a different color so you can differentiate the two. But you can still see the difference between one and the other. So yes, is it possible for a scatter plot to have a positive or negative association that is not linear? What is an example? What would be an example of a scatter plot that has a positive or negative association that is not linear? Oh, a curve. Good. There you go. A curve is not linear, right? You can't really draw a line through it, but you can draw a line through this, and then you can see that over here, it goes up. Like the example with the grades and the studying, right? After you get to 100, it kind of curves. It goes that way. So yes, it is possible. To try to increase the profits, a theater owner increases the price of a ticket by $25 each month. Describe a scatter plot, what it might look like if X represents the number of months and Y represents the profits. So if we put profits and then the months that you're increasing, what do you think it'll be? The profits will go down as the most increase because you're charging more each month. Yes. All right. We're going to move on to the next part, which is trend line. So for now, go ahead and swap back with your neighbor. No. All right, guys. So this is the next part. We're going to draw the trend line, and we're going to estimate the following page. 401. 401. Yes. It'll be on creating equations for the trend lines. Yesterday we just looked at them, we see if it was positive, negative, blah, 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 blah. Now we're going to create the actual equation. We're going to approximate the equation of the line on these trend lines. So go ahead and plot all those points. I suggest you go one by one, even though they don't go in order from least to greatest. Just go one by one so you can plot them all. I'll give you about 2 minutes. Oh, okay. Let's plot them. So 4 and 38 around here. Then 2 and 25. 1 and 7. 2, 16. 326 around here. 4 and 45. So as you notice, if we were talking about a function, this wouldn't pass, right? Because we have more than one dot over the same x. So whenever you do the line test, it doesn't pass it. But this is just a trend, like this is scatter plots. This is a different story. And we can tell there is a relationship here, right? What is the association? It's positive. What can you tell me about it? Yes, the longer the distance, the longer it takes you to finish it, right? Do you think this line will stop or indefinitely, forever? What would happen? We're talking about Joyce. This is a person doing this stuff. She'll stop. She'll get tired, right? At some point, she'll get tired, and then she won't be running as much. Well, okay, so draw a line. We already did. Use the train line to predict how long it would take Joyce to run 4.5 miles. What do you do that? What? About what? Yeah, so you basically draw a line through it, and then you go to 4.5, sorry. About 45, if you ask me, right? 50 will be right over here at 5. Do you see that? So I would say about 45 minutes. Be very close to the line. And make sure your lines and dots are on both sides, not just on one.
I got 50.
I know.
Yeah, okay.
All right, started from here. I guess, yeah, I could get a little higher. Yep, that makes sense. What? So this is information of the days. Whenever you're training, almost every day you go running for a while. So let's say she started on the 1 mile and it took her 7 minutes. And then whenever she started running 2 miles, she kept increasing or decreasing in time depending on how it went. It looks like she decreased in time. So it took her 25 minutes, then 16 minutes, then 20 minutes. So these are different days. She's just looking at how, basically the relationship between the two. But using all this information, this is not happening one day. This information from many days, and then she put them all on a graph. How well does your trend line fit the data? Like your line that you drew. Does it make sense with the data?
Yes.
Yeah. The longer the distance, the longer the time it takes you, right, to run it. However, the more you run, you should get faster. So that means you shouldn't be increasing the time. Yeah. Do you think you can use a scatter plot that shows no association to make predictions?
No, because it won't happen at the end.
You don't know where it's going to land, right? But you can say that you don't know. So that's a prediction. So when you see a kid and you're like, well, Sometimes he does well, sometimes he doesn't. Your prediction is that you don't know where he's gonna land. That's still a prediction. What's so funny over there? LOL. All right, so we did a little bit of this yesterday, and guess who came back? This guy. I know, but guess what? You can use that or Rise of a Run. So I just want you to be very careful with it. Here is the part where it is extremely important that you put the line in the right spot. Because if you draw the line above or below the dot and not right through the middle, you're going to get the wrong slope. So basically, you're looking for the slope so you can create your equation in the form of mx plus b, which is the slope-intercept form, right? Right here, we're talking about the relationship between the number of chapters in a book and the total number of pages. So use it as an example, your book. The more chapters you have, obviously, the more pages you need, right? So as you can tell, the more chapters you have over here, the pages increases, right? And then for this one, they use 2 points, 5 and 50, which is right around 2. Well, that's going by 2s, right? 4, 6. So around here, and 50, that's right on the dot. And then they used 17 and 170. So 17 around here. So in other words, you have to use points that are right on the line that you drew. I cannot use this point and that point, because if I do that, I'm going to draw this line. I cannot use this point and this point because I end up with that line. And neither of those two lines are going with the main trend. So be careful with those. It has to be on the line. And I'm pretty sure you already know how to do that. You know the B. The B over here is 0. It started at 0. What does that make sense that it started at 0? Why does it make sense that this line started at 0? The what? Yeah, you got to start at the beginning of the book. And when you start a book, you have no chapters and you have no pages, right? 0, 0. Once you write a chapter, now you have pages. Good. So now you basically want to turn it into this kind of thing. You want the equation. What type of association does the plot show? Plot show. Positive, right? It's a positive association. What is the meaning of the slope in this situation? Yes, basically the rate of the chapters to pages, right? The more chapters you write, the more pages you need. All right, the meaning of the y-intercept, we just talked about that. It was 0, 0 because at the beginning you have nothing, right? Your turn. Go over this one, analyze it, and see if you can figure it out. So there are no points on the line. When? So what do? Well, that's a lie. I can see a point on the line, at least one. The origin, and if you follow this line, you will find one over here. But those are the ones that are exactly right at the intersection of the two squares, right? So, where? It has to be on the line. These are close to it, but it will still give you a different line. Hang on. Notice what happens when I grab this one right here. It's not. It's off. I can see the intersection of the 1 and 1. So when you don't have a point on the line, just use where the line crosses the intersection. So you can do it 2 ways. Let's do it the hard way first. By using the formula, the slope formula of y2 minus y1 over x2 minus x1. Now, these are going to be our 1 values, right? This is my first coordinate. And this is my second coordinate, which is 10 and 9. And this is going to be my 2's, right? So this is x2 and y2. This is x1 and y1. And all I have to do is plug them in here, right? So what is y2? What? Y2 is 9. What is y1? That's 0, 0. That's the origin. X2 is 10 minus 0, right? So when you solve, you get 9 over 10, right? So your slope will be 9 over 10. You can do it also by rise over run. You know that you have a point right here and another one over here. So you go rise 1, 2, 3, 4, 5, 6, 7, 8, 9. And the run is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, it's the same thing. The rise over run and the formula will give you the same thing. So all you have to do is write down y equals 9 over 10 x. And you don't have a b because you started at the origin. So you can say that the number of rainy days, the more you sell umbrellas, right? Which makes perfect sense. Next one, making predictions. Use the equation of the trend line for example 1, which is the one at the very beginning. Where are you going? We have like 8 minutes. And double homework now. Keep moving. Don't move. So basically, this was happening. We use the y to make predictions, the formula to make predictions. So if we go up to this right here, was it that one? No, it was this one right here. If we come over here and we look at the number of chapters and the number of pages, there are 2 words that they use. Where is it? No. Where did it go? That's up here. Interpolation and extrapolation. And then you're like, what is that? Well, interpolation right here, that means that you're using the equation that you just found to get information inside what you have. So between 0 and 18 or 20. That means you're using the formula to find the value of x or whatever it is within that information. Extrapolation to find the value of y. So for example, let me make an example real quick. If we have the formula, this is y equals 10x, right? Right? So if it's y equals 10x, and I'm asking you, how many pages, thank you, how many pages will you have if you have 8 chapters? What do? You substitute for 8, right? You put 10 times 8 chapters. What does it get? That means 80. We look for values inside this information, right? I said 8. But what if I say, how many pages approximately would this person have after 26 chapters? What do? You plug it in, right? 10 times 26 gives me 260, right? That's called extrapolation because we're using information outside of the graph. 26 is way over here. It's way outside of the graph. We're making predictions. The other one, we're looking inside. Extra means outside. Enter, inside, extra, outside. Do we have a question on that? Are you sure you're not confused? Okay, but you can use it. So your question over here was, you have a lot. So we just answered the question. It would be y equals 10x, right? 10 times 26 chapters gives me 260 60 pages. That would be my answer. And it's an extrapolation because we use numbers that are outside the range that we were given, right?
Yes.
Now predict how many pages would be for 14 chapters. Well, that'll be 140, right? And that'll be enter because it's inside. No? Oh, it goes to 10, right? JK, still out. Okay. Do you think extrapolation or enter is more accurate?
Enter,
Why enter?
because it's on the graph.
It's already there, right? You already have that information. The other one you're predicting. This might happen. For the enter, this is what you already have. It's already happened. Okay, so
405.
let's do this one, this one, this one, and this one for your DLL. You have 3 minutes. It's very easy. Trust me.
What's the homework?
Don't worry about it. You'll have homework. Don't worry about it. Work on this now. Ahora.
We still need this, or we can put it away.
I just said don't worry about it. But it'll be this page in the back. Ugh. Yeah, front and back.